The hunt was over. The winter problem had only begun. A reindeer carcass could hold more food than a group could eat at once. But meat was not the same as usable energy. Not every part repaid the work of cutting and carrying it, and one kill could not feed anyone after the herd had moved on. At Jonzac, in western France, reindeer were butchered during autumn and winter. Meat was removed. Long bones were opened for marrow. The remains fit repeated short visits, better than one permanent pantry. Feeding a group through winter meant reaching prey at the right time, securing high-return animals, extracting the richest tissues, and repeating those decisions before cold and distance consumed the return. The kill was one moment. The food system began before it and continued after it. But the bones preserved the meals, not the plan. They cannot tell us the exact number of people, the rules of sharing, or whether a surplus was stored, eaten quickly, or consumed when more people gathered. To understand why one kill was never a season, we have to begin with the invisible thing winter was spending every hour: energy. Cold is easy to picture. Energy loss is harder. A body must keep its core within a narrow range. When the air grows colder, heat escapes across exposed skin, through clothing, and with every breath. Wind strips away the thin layer of warm air close to the body. Wet material can accelerate that loss. Muscles then create more heat, sometimes through visible shivering and sometimes through subtler changes in metabolism. But producing heat is only the first charge on the winter budget. Food is rarely waiting at the edge of camp. People must walk to find tracks, climb or cross uneven ground, carry stone and wooden equipment, approach dangerous animals, butcher them, and move useful parts. Every solution requires work, and that work consumes some of the energy it is meant to recover. Winter therefore spends energy twice. It raises the cost of staying warm while making replacement calories more expensive to reach. This does not mean every Neanderthal day was a desperate march through deep snow. Conditions differed across western Eurasia, across millennia, and from one valley to another. A sheltered woodland during a milder interval was not the same environment as an exposed steppe during a cold stage. Nor did every person carry the same burden. Body size, age, health, activity, clothing, shelter, and wind all mattered. Still, the basic constraint remained. A group could not plan only around how much food an animal contained. It also had to consider how much effort would be spent finding that animal, how much could be recovered, and how long the return would last. That is why a winter food system begins before anyone throws a weapon. It begins as a balance between distance, opportunity, risk, and time. To feel the scale of that balance, researchers have tried to estimate the cost. Their models are useful, but the apparent precision of a calorie number can also create the first major trap in this story. One influential model of Neanderthal energetics estimated that strenuous winter foraging and resistance to cold could require roughly 3,360 to 4,480 kilocalories per day. That range is large enough to make the problem physical. It is also uncertain enough to stop us from turning it into a prehistoric grocery bill. The estimate is not a reading taken from a Neanderthal body. It was built from assumptions about body mass, activity, climate, and comparisons with recent human populations living in cold environments. Change those assumptions and the total changes. A large adult moving for hours through exposed terrain would not spend energy like a child remaining near shelter. A calm day would not cost the same as a wet, windy one. A short burst of intense work would not equal a full day of travel. This matters because it is tempting to choose a group size, multiply by a daily requirement, multiply again by 90 winter days, and announce exactly how many reindeer were needed. Archaeology does not permit that calculation. We do not know the exact number or age structure of the people represented at Jonzac. We do not know how many days any one person remained there. We do not know the complete balance of meat, fat, plants, or other foods consumed away from the site. Even the boundaries of winter are not a single 90-day block that every group experience in the same way. The model can tell us that the energy burden was high. It cannot tell us the ration schedule of one camp. That limit is not a dead end. It changes what we should look for. Instead of trying to reconstruct a perfect menu from an imagined family, we can ask how people reduced the largest sources of risk. Could they arrive where prey became seasonally available? Could they obtain enough return to justify the journey? Could they extract more than the obvious meat? Could they carry or share a surplus before it was lost? Those questions move us from an uncertain denominator to evidence that actually survives. And at Jonzac, that evidence begins with the calendar written into reindeer remains. Hunger is immediate. Seasonal planning is not. By the time a landscape is already locked into its leanest months, the easiest choices may have disappeared. Plants become less available. Daylight contracts, some animals disperse. Others move along routes shaped by forage, shelter, mating, or snow. The location that was productive in one part of the year may become empty in another. The first winter food decision was therefore not simply what to hunt. It was where to be when a particular opportunity opened. Reindeer are especially useful to this story because their lives are strongly seasonal. Their movement, physical condition, and grouping change through the year. A concentration of animals can create a valuable window, but that window does not remain open indefinitely. At Jonzac, the mortality pattern of the reindeer places hunting from autumn into winter. The assemblage includes different age classes, with adults dominating. It is not the signature of one convenient animal taken beside a long-term home. It records repeated access to a high-return prey resource during a restricted part of the year. A plausible sequence is movement towards such an opportunity before the greatest scarcity arrived. The archaeological record does not preserve the route, the departure date, or a spoken plan. It does preserve enough seasonality to show that the use of this place was tied to time. Mobility, in that sense, was not random wandering. It was a way of preventing distance from becoming fatal. Moving closer to prey lowered the cost of repeated access. It also allowed people to exploit a concentration without transporting every part of every carcass across an entire region. But mobility imposed costs of its own. People carried tools, fuel knowledge, hides, and whatever food or materials they chose not to abandon. A wrong turn or a late arrival could spend energy without recovering it. The winter system, therefore, depended on synchronization. The group had to arrive neither after the opportunity had passed, nor so early that waiting erased the advantage. This is the seasonal clock behind the episode. The resource changes, the distance changes. The value of a decision changes with them. And when we enter Jonzac through that clock, the 18 reindeer stop looking like shelves in a pantry. They begin to look like a sequence of returns. The number is striking. At least 18 reindeer, but a minimum count is not a scene. It does not mean 18 animals fell together. It does not mean one group killed them all in a single winter. Archaeological layers can accumulate through repeated visits, and later processes can mix or remove parts of what was once present. The responsible question is not, what happened on that one day? It is, what pattern best explains what remains? At Jonzac, the pattern combines seasonality with intensive carcass use. Reindeer were taken from autumn through winter. Cut marks show butchery and the removal of meat. Broken long bones show access to marrow. Adults predominate, but the assemblage is not restricted to a single narrow age class. These animals were not merely scavenged after every valuable tissue had disappeared. Neanderthals gained substantial returns from them. At the same time, the site contains very little evidence of hearth activity or burned bone. That absence must be handled carefully. It does not prove that no flame ever burned there. Hearths can be cleaned, disturbed, missed by excavation, or leave traces that do not survive equally well. Absence of evidence is not evidence that an activity never occurred. Yet the near absence of fire traces matters when it is combined with the rest of the assemblage. The site study interprets Jonzac as a place visited repeatedly for relatively short periods by highly mobile hunter-gatherers. It fits a station inside a moving food system better than a permanent residential camp stocked for months. That distinction changes the title question. Feeding a group through winter does not have to mean keeping the same people inside the same cave beside one cache. It can mean maintaining access across a sequence of places and decisions. A landscape can function as part of the food system when people know when to enter it, what to take, and when to leave. Jonzac gives us a direct anchor for 3 parts of that system: seasonal timing, repeat access, and intensive processing. It does not give us the complete map. We cannot trace every movement before or after a visit. We cannot assign each animal to a particular set of people. We cannot see what food was carried away, what was eaten nearby, or what may have been consumed at sites not yet found. We certainly cannot turn 18 reindeer into an exact number of winter meals, but the pattern allows a stronger conclusion than any invented camp roster. These Neanderthals repeatedly reached a place where high-return prey was seasonally available, and they converted those encounters into meat and marrow. Reaching the animals solved the first problem: access. It immediately created the next one. A living reindeer was not food. It was a dangerous, moving concentration of energy that still had to be stopped. Large prey offer a powerful bargain. One successful encounter can return far more energy than many small encounters. The carcass also concentrates multiple resources in one place: meat, fat, marrow, hide, sinew, and bone. But the bargain is paid in risk. An animal can detect an approach and flee. A group can spend hours following tracks and recover nothing. A weapon can miss or fail to penetrate deeply enough. A wounded animal can escape or turn on the people closing the distance. Injury has consequences beyond the individual. A person unable to walk or work changes the energy balance of everyone who remains with them. We should not pretend to know the precise choreography at Jonzac. The site does not preserve the number of hunters, their formation, or the exact weapon used against each reindeer. Any visual reconstruction must therefore remain restrained. Approach, danger, impact, pursuit, and uncertainty without invented commands or heroic roles. What the animal remains show is that acquisition succeeded repeatedly, that repetition matters more than one spectacular hunt. A winter system cannot depend on a single moment of courage that never has to happen again. It needs knowledge that can produce another opportunity. Where animals move, how terrain channels them, how wind carries scent, how to approach, and how to recover after failure. The same knowledge also determines whether a high-return strategy is worth its cost. Travel too far for too little meat, and the energy budget contracts. Spend too long pursuing one animal, and daylight or weather can close the window. Succeed, and the group faces a different clock. The carcass begins to cool. Other scavengers may locate it. People are tired. Useful tissues differ in value, weight, and accessibility. Everything cannot be carried with equal ease. The hunt has ended. The deadline has not. From a distance, a carcass looks like one object. At the cutting edge, it becomes a field of decisions. Some tissues can be removed quickly. Others require more time. A large muscle may offer a substantial return, but add weight to the journey. A joint contains useful connective tissue, but demands careful separation. A long bone is heavy, yet the marrow inside can justify carrying or opening it. Low-return parts may cost more labor than they repay under the conditions of that moment. Cut marks at Jonzac show that Neanderthals filleted meat from reindeer carcasses. Fractured bones show that they opened access to marrow. These are direct traces of processing, but the exact sequence around them is reconstructed. One plausible sequence is triage. People first open the carcass and remove high-return tissues. They separate portions that can be eaten, processed further, or transported. They decide whether to open heavy bones at the site or move them elsewhere. The choices could change with distance, daylight, temperature, danger, and the physical condition of the people doing the work. We cannot assign those tasks to men, women, elders, or children. We cannot recover a fixed division of labor from a cut mark. What we can see is dependency. Killing without butchery leaves most of the return trapped inside the body. Butchery without transport can strand useful food. Transporting everything can waste energy on weight that offers too little benefit. This is why carcass processing belongs at the center of the winter answer. The animal does not feed the group merely because it is dead. It feeds the group only as anatomy is converted into usable portions before time, effort, or loss overwhelms the return. Cold could sometimes slow decay. It could also freeze tissues, stiffen hands, cover roots, and make processing harder. We do not need to choose one universal effect. Temperature altered the deadline. It did not remove it. The bones at Jonzac preserve successful choices, but not every rejected one. The pieces left at a site are not a complete inventory of what the animal offered. They are the remains of what people removed, opened, consumed, carried, abandoned, or lost, filtered again by thousands of years of preservation. Even with that filter, one decision is unmistakable. Neanderthals did not stop after taking the easiest meat. They broke bones to reach marrow. That action opens the most important energetic turn in the film, because the visible mass of an animal and the energy it can actually deliver are not the same thing. Lean meat is valuable. It supplies protein, water, minerals, and energy. But the human body cannot treat all food energy as interchangeable without limit. Protein is essential for building and repairing tissue. It can also be used as fuel, yet processing very large quantities of protein places limits on metabolism. Fat, by contrast, is far more energy-dense. In a season of high expenditure, access to fat can change the value of an entire carcass. That does not make Neanderthals obligate meat eaters, and it does not prove that any group at Jonzac suffered from a specific nutritional crisis. It means only that kilograms of lean tissue are a poor measure of how long a kill can support demanding activity. An animal's condition changes through the year. Fat reserves rise and fall with feeding, reproduction, migration, and winter stress. The same species can offer a different energetic return in autumn than it does late in a lean season. A hunter is therefore not only encountering an animal, they are encountering that animal at one point in an annual cycle. Marrow offers one concentrated source of fat. Long bones protected inside hard walls. Opening them requires force and creates recognizable fracture patterns. At Jonzac, marrow exploitation is part of the direct record, but marrow is not the only lipid stored in bone. Spongy tissue around joints and inside some bone ends can retain grease after the central marrow cavity has been emptied. Recovering that grease demands more work. The bones must be reduced into smaller fragments. The fragments must be heated in water so fat can separate and rise. Fuel, water, a workable container, time, and coordinated labor all become part of the return. This is a different kind of extraction. It is not the quick reward of splitting one shaft. It is the decision to spend more effort for nutrients that are harder to reach. At Jonzac, we have direct evidence for meat removal and marrow extraction. We do not have direct evidence there for a full grease rendering operation. To see that capacity clearly, we must move to another site, another period, and another environmental context. That move is useful only if the distance remains visible. The comparison comes from Neumark-Nord 2, in what is now Germany, around 125,000 years ago, during a warmer interglacial world. It is not Jonzac in winter. What survives there changes what we know Neanderthals were capable of doing with bone. At Neumark-Nord 2, the pattern is larger than a few broken bones beside a meal. Researchers documented the systematic processing of bones from many large mammals. Dense shaft fragments and grease-rich spongy parts were treated differently. The bones selected for within-bone nutrients were broken down with an intensity and organization consistent with large-scale grease production. The phrase, "fat factory," is useful because it captures the scale of the operation. It can also mislead if we imagine permanent buildings, specialized workers, or pottery vessels. None of those details is required by the evidence. The physical mechanism is simple. Break grease-rich bone into small pieces. Heat those pieces in water. Fat separates from the tissue and can be collected from the surface. The smaller fragments increase the area exposed to heat and water, but creating them costs labor. A container is necessary, yet the exact container does not survive. Organic materials such as hide, bark, or a lined pit are possibilities, not confirmed objects at the site. What survives is the processing pattern. Neanderthals did not merely crack the easiest marrow cavities and walk away. At this locality, they organized repeated work to recover nutrients still locked inside bone. That demonstrates technical knowledge, patience, and the ability to coordinate a chain of tasks whose reward arrived only after additional processing. For P7, Neumark-Nord supports a mechanism, not a winter scene. The climate was different. The prey community was different. The locality was a lakeside setting during an interglacial. We cannot copy the operation onto Jonzac and say the reindeer bones there were boiled for grease. The Jonzac evidence does not establish that. What we can say is more precise. Neanderthals possessed the capacity, in at least one well-documented context, to extract energy from bone at a scale beyond immediate marrow consumption. This expands the range of possible food processing behaviors available to Neanderthal groups. It also shows why carcass value cannot be estimated from meat alone. The comparison reveals another trade-off. More complete extraction increases the return from an animal, but it also requires time, fuel, water, and labor. It makes sense only when the recovered nutrients justify those costs. A food system was therefore not driven by maximum extraction at all times. It was driven by decisions about when extra work paid. That principle connects the fragments of Neumark-Nord to the reindeer of Jonzac. In both cases, people were not passive recipients of whatever an animal offered. Processing changed the amount and kind of energy available. Yet even perfect processing cannot solve one final property of a large carcass. Food can arrive faster than a small group can consume it. When that happens, abundance becomes a logistics problem. The clearest version of this problem appears not with reindeer, but with elephants. At several sites on the northern European plain, Neanderthals intensively processed straight-tusked elephants. These animals were much larger than modern African elephants. A single adult carcass could contain an enormous quantity of edible tissue, far beyond what a small local group could finish immediately. The evidence shows exploitation. It does not preserve one social solution. One possibility is storage. Cold conditions, drying, smoking, or other techniques can extend the life of food. But the elephant cases do not identify one exact preservation method that can be transferred to every site. We should not fill a cave with frozen meat simply because the image feels practical. A second possibility is temporary aggregation. More people may have gathered when a huge surplus became available. That would turn one carcass into a social concentration as well as a food source. A third possibility is a combination: consume some quickly, distribute some, process selected portions, and preserve what conditions and knowledge allowed. The archaeological evidence cannot yet decide exactly how these options were balanced in each case. That uncertainty is not an excuse to avoid the problem. It is the problem. A giant kill does not automatically equal long-term security. Food must be protected from microbes, scavengers, moisture, thawing, and theft. It must remain accessible to the people expected to consume it. Processing requires labor at the moment when people may already be exhausted from acquisition. If more consumers gather, the surplus disappears faster, but the event may strengthen relationships through sharing and reciprocal access. If food is carried away, transport spends part of the energy being saved. Every response moves cost from one part of the system to another. The elephant evidence, therefore, gives us a bounded lesson for the winter case. Large prey can create enough surplus to demand storage, rapid consumption, wider sharing, temporary aggregation, or some mixture of them. It cannot tell us that the reindeer at Jonzac were preserved by one name technique, or that one exact number of people ate them. For Jonzac, those details remain open. Meat may have been consumed near the kill, transported to another place, preserved under favorable conditions, shared among people not represented at the site, or handled in several ways across repeated visits. The bones alone do not choose one scenario, but they narrow the space of responsible reconstruction. Any system capable of feeding a group repeatedly had to manage irregular arrival. Hunts do not produce equal returns on a schedule. Some fail. Some yield more food than can be used immediately. The group had to absorb both shortage and surplus without knowing which would come next. Before we turn that requirement into a social story, one final simplification must be removed. Large animal food was important in many Neanderthal contexts. It was not one universal menu for an entire species. Neanderthals lived across different environments for hundreds of thousands of years. Their food could not remain identical across all of them. At Père, in southeastern France, microscopic and chemical traces associated with stone tools point to the use of mammals, fish, birds, starchy plants, and wood. Other sites add their own combinations of large game, small animals, aquatic resources, and plant foods. Stable isotope studies often place European Neanderthals at a high trophic level, consistent with substantial reliance on animal foods in the individuals examined. Those results are important. They are not a complete seasonal menu. Some methods are more sensitive to protein sources than to the full contribution of plants or fat, and a handful of individuals cannot represent every region. The boundary matters because this episode follows a cold stage, Western European large game system anchored at Jonzac. It does not define what every Neanderthal ate from the Mediterranean coast to the Eurasian interior. Local opportunity shaped the mix, where fish, shellfish, birds, small mammals, edible plants, or stored carbohydrates were accessible. They could reduce dependence on one prey species. Where winter narrowed those options, large herbivores and the fat inside their bodies may have become more consequential. Dietary flexibility itself can act as insurance, but only when the landscape supplies alternatives and people know how to use them. This does not weaken the reindeer case. It clarifies it. Jonzac shows one strong response to a particular seasonal opportunity. Père reminds us not to turn that response into a biological destiny called the Neanderthal diet. Across those differences, one requirement persists. Food must move from an unpredictable landscape into multiple human bodies. That transfer is never purely nutritional. It depends on decisions shared across a group. Archaeology often preserves the result of coordination more clearly than the rules that produced it. A reindeer bone with cut marks tells us that a blade passed across tissue. It does not tell us who held the tool. A broken shaft records access to marrow. It does not name the person who carried the bone, struck it, or ate from it. A seasonal assemblage records repeated success. It does not preserve the conversation that brought people back. Yet the food system described by these traces is difficult to imagine as a series of isolated acts. Someone must recognize the seasonal opportunity. People must while supporting those who cannot travel or work at the same pace. A hunt must place enough effort in the right location without exposing every person to the same risk. Once an animal is down, cutting, breaking, carrying, protecting, and consuming food become linked tasks. Knowledge must survive the failure of one individual and extend beyond one day. We do not need to invent fixed roles to see that dependency. The same person may have performed several tasks. Different people may have shifted roles with age, injury, skill, pregnancy, weather, or circumstance. Some knowledge may have been widely shared. Other knowledge may have been concentrated in experienced individuals. The evidence does not resolve those arrangements. What it does resolve is the weakness of the solitary hunter image. One person can make a cut mark. A winter food system requires continuity. It requires someone to remember where prey appeared, someone to maintain tools and materials, someone to transform a carcass before its value falls, and a social setting in which food reaches people who did not personally deliver the killing blow. Sharing is not preserved as a written rule, but feeding an entire group necessarily moves energy across unequal moments of success. Children cannot acquire large game. An injured adult may be unable to hunt. A hunter who fails on one day may eat because another succeeds. Even without knowing the exact arrangement, group life changes the risk carried by each body. That may be the deepest advantage of coordination. It does not guarantee abundance, it distributes uncertainty. The material record cannot tell us whether food was divided equally, according to need, according to status, or through relationships that changed from event to event. It cannot give us the size of the camp or prove that every person belonged to one family. Any reconstruction that assigns modern domestic roles would exceed the evidence. But the chain of dependencies remains visible. Locate, approach, kill, butcher, extract, carry, share, and decide when to leave. Remove one link, and the energy trapped in the landscape fails to reach the group. That is why the final test of this winter system is not a perfect hunt. It is failure. Miss the herd, and movement becomes an expense without a return. Find the herd, but fail the hunt, and time, daylight, and strength are spent for nothing. Make the kill, but ignore the densest nutrients, and a large carcass provides fewer usable days than its size suggests. Create a surplus, but fail to consume, share, move, or preserve it in time, and abundance decays beyond reach. These are not 4 separate stories. They are 4 points where one system can break. Seasonal knowledge reduces the chance of missing prey. Cooperative acquisition raises the chance of a high return while distributing some of the risk. Selective butchery and marrow or grease extraction increase the useful energy recovered from a carcass. Social coordination helps absorb the uneven rhythm of failure and surplus. None of those solutions is free. Mobility costs energy. Hunting risks injury. Intensive processing costs time and fuel. Sharing increases the number of consumers. Storage, when possible, demands labor and can still fail. The system works not because one technique defeats winter, but because each decision protects the value created by the one before it. This also explains why intelligence cannot be reduced to a clever tool. The critical knowledge is relational. When does movement repay its cost? Which part of an animal justifies its weight? When does extra processing produce more energy than it consumes? When should a group remain, divide, gather, or move on? We cannot hear Neanderthal answers to those questions. We can see the material consequences when enough of their answers worked, At Jonzac, those consequences are still lying in broken reindeer bones. Return to the first carcass. At the beginning, it looked like an answer, a large body holding enough food to defeat the cold. Now it looks different. Before it can feed anyone, people must reach it at the right season. They must accept the risk of acquisition. They must separate high-return tissues from costly weight. They must open bone to reach fat, decide when further processing is worth the work, and manage food that may arrive in either shortage or surplus. Then they must move that energy across a group whose exact size and rules are lost. That is how Neanderthals could feed people through winter, not with one permanent pantry, not with one heroic kill, and not through a single universal diet. The best supported answer is a distributed system. Seasonal timing, mobility, repeated high-return hunting, intensive use of carcasses, and social coordination. Jonzac directly preserves part of that system in reindeer hunted from autumn through winter, filleted for meat, and opened for marrow during repeated short visits. Neumark-Nord shows, in another climate and period, how far within bone extraction could be taken. The elephant sites reveal the logistics created by surplus. Other dietary evidence keeps the answer tied to its region and context. Some of the most cinematic details remain unknown. We do not know the exact camp roster. We do not know the division of labor. We cannot say whether the Jonzac reindeer were frozen, dried, smoked, cached, eaten quickly, or handled differently from one visit to the next. We cannot turn cut marks into a ration schedule. But uncertainty does not erase the system. It defines its responsible boundary. 18 reindeer no longer represent one mountain of meat. They represent repeated encounters between a moving group and a moving resource. Each encounter converted knowledge into calories and calories into time. The bones preserve those meals. The plan that connected them has disappeared.